Today, we are going to learn about AI, and I'm happy to present Karen Kilroy of Kilroy Blockchains. She's a lifelong technologist with heart, a full-stack software engineer, and an IBM champion. And this is her third publication.
Hi, everybody. Thanks. Thanks for coming out and spending your lunchtime with me. I really appreciate it. And what I'm going to talk to you today is something I've been pretty immersed in for the last, 6 years, I think, artificial intelligence. We're going to talk about what makes it so smart anyway. Sometimes when I rent cars or something that's got the full artificial intelligence controls, I start calling it smarty pants. I call it smarty pants no matter what it's in my phone or TV or anything. But yeah, what makes it so smart? So we're going to talk about that. And I'm Karen Kilroy, and I'm the author of Blockchain Tethered AI, and also AI and the Law, and then another publication for O'Reilly called Blockchain as a Service. Now, robots and computers are to the point now where they can create art, music, films, they can tell stories, they can write programs. It's just, how many people have seen any of this for themselves, where they go online and they ask the computer to make a story for them, for instance? Yes, I said, what'd you think of that? It's pretty neat, isn't it? It surprised me, I know. And I'm around this stuff all the time, and I was still surprised at how fast it had advanced. And I started writing my book in December of 2021, and then and then we were finished in February. So it was amazing, the timing that all of a sudden it went into artificial intelligence mania. Now things have kind of switched to where, I used to go put on a record or a movie or something or read a book, and, I would be pulled into the experience that the content creator wanted me to have. But it's kind of changed, hasn't it? Like, you're at the center of it, you're generating it, you're making it happen as you go along. And these images I'm showing you are all created by artificial intelligence, just by typing in some words. I would like some elephants in front of a swirly background. And it does it for you. And it used to take, an artist a long time to do this type of work. And then as they learn, and we're going to talk about how the computers learn, but they just get better and better at what they're doing. And again, this is all automatically generated out of Adobe Firefly is what I use for these. It's in a beta program right now, which means it's free. Anybody can sign up and request access to it. Now, how in the world does it do this? How does it do it? I think I told it I wanted 2 musical lovebirds or something like that, and that's what it gave me. And how does it even begin to do this? Well, the first thing we want to do is ask, what is artificial intelligence? What's a definition? And there's a lot of discussion about this, even among the top experts. There's not really a lot of agreement, but I've noticed that when I give this definition, nobody argues. It's a real intelligence created artificially. So it's done through a process called machine learning, which is critical to how it works. Another thing that makes artificial intelligence different from a regular, like a piece of software like Excel for doing spreadsheets, is it doesn't wait for us to turn it on. If Excel were artificial intelligence, you might turn it on and it might say, I got that budget done for next month, and if you're thinking about taking a trip, here's some good possibilities, and I researched this while you were asleep. And so that's the difference of how it's going to work for us. So there's some basic terminology that I'll tell you, just so you'll hear me using these words a lot. For the sake of calling it something, we call AI models. And there's all different kinds of artificial intelligence being used throughout the world in different things, from cars to chatbot systems to televisions to pretty much everything. It's going to start creeping into everything, but they're all different. It's not just like one big AI, even though we tend to like call it AI. They're AI models. So they're different software programs created by different groups of people. And then machine learning is the process used to train the AI model. Now, the machine learning uses something called training data. And it's like a special teacher that teaches the model how to do some specific thing. So let's say, for instance, I'm trying to teach the model how to draw, a sailor in a sailor suit. And so I might give it 1,000 images of drawings of sailors and sailor suits, and then I might give it 1,000 images that sort of look like sailors and sailor suits, but they're something else. And so I train it what it is and what it isn't, and then eventually it would learn how to draw that for me. And that can apply to anything. Let's say I know how to build houses, and I'm teaching it how to build a house, and so I'd give it all these different examples of houses that are built properly and examples of mistakes that could happen, and then eventually it knows how to build a house. Now the thing is it learns really similar to how we learn. It's just way faster than we learn, and everything is just so fast. It thinks so fast, it's really incredible. Now, what's behind all this under the covers? You should have listened to your math teacher, right? If you did, right now, I wish I'd listened more to mine, because that's what this is all built on. Mathematical models are what's underneath the covers. And so, if someone really wanted to master AI and understand it, I would suggest to them, that's what to do. The way to really get your hands around that magic is to understand the math. My friend Helen Nelson wrote this book, also out on O'Reilly, Essential Math for AI, and I recommend this one also. So let's wind the time machine back a little bit to 2017, and I mentioned that I've been working on AI for a while, and this started when I worked on a project called Riley, and Riley was built by my company Kilroy Blockchain, and we won the IBM Watson Build Award for Riley way back in 2017 for all of North America. Now, Riley came about because in my other life, this is my other job that I do when I'm not doing software engineering, is I'm a dragon boat coach. Has anybody ever seen a dragon boat before? They're cool, and there's a dragon boat race coming up in Little Rock, June 8th through the 10th, I think is that range, that weekend. And usually they run them like corporate challenge type things that people come out and do it once a year, and it's a really good way to build teams. Sometimes people with special needs do dragon boating as a way to lift spirits. Like I coached breast cancer survivors for a long time. In Austin, I was coaching kids who were blind and visually impaired from the Texas School for the Blind. And we spent a lot of time with the kids. They practiced a really long time to be able to do this race. And so one of the things I noticed was that when the kids got bored, the phones came out. Just like any other teenager, the phones came out, and also the headsets go on. So they got the whole audio phone experience. And the thing is I was just starting to learn AI. And I thought, I bet you could pick something up where you could point that phone around and it would tell them what the phone sees. And so we got that idea for Riley, and we entered the IBM Watson Build, and we just kept winning and winning and winning, and eventually we had a product. So those are some of the things that Riley was designed to do. You'll notice the logo has the little cane with the red tip, the white cane with the red tip in part of the door frame. to symbolize it's always for people who are blind and visually impaired. But it can also help other people. Like, I've heard there's a company up here that just recently got funded for wearables that help you learn jobs. And that's, Riley does that too. You can point it at something and it would tell you, oh, that's this type of a screw, and you use this tool when you're putting this type of a screw in for this application. So you can do all different kinds of things with it. So this is what got me started. Now, getting back to the topic of training data, this is my dog, Iggy Pup. Iggy Pup, he's a Rhodesian Ridgeback, and Riley misidentified Iggy Pup. You pointed at Iggy from the front and knew what he was. He'd say, that's a Rhodesian Ridgeback. But from the back, he'd say, that's a duck-billed platypus. You'd be like, well, I can kind of see it. But there's the real Iggy Pup, just so you can tell over there. Who can tell me how I would make it identify Iggy? What would I have to give it to make it do a better job?
More training data.
More training data, yes, exactly. That's exactly right. And so you want to talk about that just a little bit more and tell me what kind of training data I would want to give it?
If it doesn't identify Iggy from the back, you can take a lot more pictures of the back and provide that to the model to train it. That's a good example.
Yes, exactly. He said give it more pictures of Iggy from the back to tell it that this is a Rhodesian Ridgeback from the back, and so would be able to identify it better later. AI trainer, that's who would do that, right? An AI trainer would do that. And so that's one of the new jobs. You keep hearing people say, well, AI is going to take all our jobs. And just the other day, IBM announced, well, we're cutting 8,500 jobs that are being replaced by AI. They just came right out and said it. Now, this is on the tail end of the 500,000 layoffs in the tech industry where they didn't come out and say it. I kind of thought that the whole time, but IBM is not, they're just coming right out and saying it. These jobs won't be back. They're gone. They're going to be automated. And so I hear people say all the time, well, there'll be new jobs. Be new jobs. It's like, well, okay, wouldn't it be a good time to start telling people what the new jobs are? Because they're laid off and their money's probably going to run out pretty soon. Probably be a good time to start talking about this. So we have the AI trainer who would do things like make it recognize Iggy Pup, a prompt engineer or a librarian, a prompt librarian. Now, a prompt engineer is someone who becomes an expert in typing things into AI to make it produce something else. So like in those first few slides, we saw those really colorful pictures and like the elephants. A prompt engineer would say, well, here's what I typed and where I typed it to get those elephants. And what you want to do with that, if you're looking at getting that type of work, and by the way, the jobs that are being advertised for it now, it won't stay like this, but they're like paying $300,000 a year for prompt engineers. And yeah, so that kind of got everybody's attention in the whole tech industry. But the thing to do if you want to go down that road is start to develop a portfolio. So let's say, for instance, your friend has a business fixing boats, and your friend says, I need to write something up about my business, like a 3-pager, and we're going to send it out to everybody who has a boat in this area, and you help them, and then you come up with this really nice marketing piece, and their business increases by 20% because you helped them. You want to record all that in a portfolio, just like as if you were an artist and say, I went to this system, I used this prompt, it produced this proposal, which got this amount of business in. And you can take that somewhere and get a job. AI product manager is another one that It's going to go across all the different verticals because all the different companies are getting into artificial intelligence at once. So let's say the hospitality industry, just randomly, they're going to have an AI product manager. The steel industry, the rubber industry, the automotive industry, on and on and on and on. Everybody's going to have somebody with that job. And they're going to be somebody that understands that business and has learned some AI. Training data content creator. Now this is something that we've been talking about a lot. We have a series at the Fayetteville Public Library. I've got Melissa Taylor here with me today from the Center of Innovation at the Fayetteville Public Library. And we have another workshop tomorrow night. These are free. And where you can learn about, we're talking about how to get people who create training data paid. Because how it is right now, these AI models, they can just crawl the web and get everybody's ideas for free. The companies are going to make millions, billions over the course of decades or centuries. We don't even know how long this stuff is going to be. And it's building on the backs of starving artists, or writers and all different kinds of content creators. So we're working on a plan to get people who create training data paid in advance of AI consuming it. So let's say, for instance, you are a videographer and you have 500 hours of extra footage that you've not used for anything. There may be a market for that to go in as training data somewhere. Tag writer, when you have the training data like this is Iggy Pup's tail, and someone or Rhodesian Ridgeback from the back, Rhodesian Ridgeback from 3/4 at an angle, sitting in a kitchen, whatever. Someone's going to have to go through and write descriptions on all those and tag them, and that's a job. Education specialist. We didn't talk about how AI education can be generative. Okay, so education. One of the things that could happen when you apply this whole, okay, I'm the center of, I'm the consumer, so I'm the center of what I'm seeing, and it's going to change based on what my interests are. You could apply that whole concept to education. So let's say, I'm interested in science, and I know I'm interested in science. Oh wait, look here, this stuff with physics looks really interesting, and now I'm going to dig away at that, and now I'm going to learn about energy, and I'm dig away at that, and so I think that we're going to see that education experience becomes more generative and led by the learner. And because the AI can kind of build the road as you're going down ahead of you. And I think we may see that that'll really spark some interest in people trying to learn things. Robotics, there's going to be all different kinds of jobs to integrate robotics. Right now, a lot of the robots that do a lot of these intricate jobs on factory floors, all over the place, those are going to end up using different right now, they're coded pretty basic, because you've got people who are hardware engineers writing code. But it's going to switch. And what I kind of expect is that Microsoft will push chat. They'll push GPT 3 or 4 as an operating system for robots. So it'll be like you won't have to write all the code. You'll just load up the windows, so to speak, and talk to it. So I think that's where that's headed. I mentioned generative a few times, generative AI, and this is where the audience is now as much a part of the creation as the artist, as the creator. So for an artist, for someone who's a content creator, you might think of things a little differently and think of, okay, if someone's producing this on the fly, maybe I'm not thinking of a big landscape with a sunset and an ocean. Maybe now I'm thinking of 15 different types of sunsets and 25 different types of oceans, and how this person might combine them based on prompts. ChatGPT, I mentioned that a few times. This is really fun to play with. You can play with the free version, and don't tell it anything that you wouldn't tell everybody. because we don't know what happens to the logs. I would say that pretty much though with anything on the internet, you really can't trust any of the companies. And make sure you start reading your fine print so you know where things are going. But this is fun. This is fun just to play with, and it'll talk to you. So when your question is, oh, I do not have personal beliefs or experiences that could influence the information that I provide. However, users can consider potential biases that may be inherent in my training data and my algorithms. Now, bias is one of the biggest problems with AI is that there's a lot of bias in data. And when we think of bias, we think, well, race, gender, things like that. But there's a lot more. I was thinking of me the other day. I think, well, I'm biased against going to a dentist where there's like 6 dentists in one office because when I was pregnant, they said I had migratory glossitis on my tongue, and I didn't know what that was, and it was weird. Now, okay, so what kind of a weird bias is that, right? Who would ever think about that? But that's an example of a bias where I might look for, a dentist that operates by themselves rather than in a large practice. So it's all kinds of biases, and you want to try to at least be aware of the biases in your data because it's going to impact how it operates. And so this is one of the things too, ChatGPT will tell you, I operate in an opaque box, meaning that the processes and calculations used to generate my responses are not visible. That's only partially true. There's someone that knows what's going on in there, despite what all the big tech CEOs are saying. They actually do know what's going on. It's not practical for a user to evaluate the vast amounts of data that I've been trained on. So it's interesting because it says you gotta think about it, but you have to look at what you're doing, but you can't because you can't see it. So it's kind of interesting. Now here I'm talking about a way where AI could go wrong, and it's been in the news a lot. Has anybody seen that Godfather of AI, Jeffrey Hinton on television, a guy that quit Google and now he's on TV everywhere? He's only one of the people that are out there saying, we've got a problem with this. We've done this in a dangerous way. It can easily get away from us, and it could very well end up smarter than we are. And this was an example of how AI could get out of control. Is let's say you tell AI, well, eliminate cancer. And so it does it by killing a bunch of people off so they can, who are genetically predisposed to it. And you can say, well, I didn't mean kill everybody, because it's too late by then. So you have to think about those kind of things ahead of time because it takes things literal. And something like that would be what you call a hyperparameter, which is like a condition around the AI, where you'd say, you can do this, this, and this, but you can't use all the electricity, so it shuts the city down. And it has to remember those things, because as the AI engineers work to make it better, so it improves and learns Ziggy better, that whole process is it's a cycle that they have to keep going through. It's a workflow. And it's actually like a scientific experiment where someone will do an improvement and they'll document what they did, and then they'll change some more variables and document that and hand it to the next scientist. And one of the big problems right now is there's no systems for it. So the AI starts to lose its intent and it starts to forget what it was for. Genetic algorithms, see, now we're starting to get into the scarier things. This is AI improving itself through a process that's like natural selection. So as it gets smarter and goes through generations, it knows to eliminate behaviors that didn't benefit it. Program synthesis, this is where AI can write its own code. It is already doing this, and that's one of the other things that makes it so scary because let's say I'm a programmer and I work at a big company, and the boss came in and said, the AI keeps calling everybody dummies in the meeting. And it's like, you gotta fix this, Karen, I gotta fix this. And I'd be like, well, I don't know where it learned that. You know, it's just like a 2-year-old, where did it learn that? And so you should be able to back up and see, okay, where did it learn that? Oh, look, someone hacked the training data and put a bunch of suggestions in here for it to call people dummies in the meeting. Now we have to back it up. But see, right now, there's no way to tell. You could just, if the AI wrote its own code, and it probably wouldn't write code that humans could read because that's inefficient. So it would write machine code, and then someone like me would not be able to figure out where it learned to call people dummies. Superintelligence. Now, superintelligence is where it gets smarter than humans and learns how to beat humans at things. There's this movie. Did anybody see this movie with Melissa McCarthy? I love this movie, and I saw it a couple of years ago when I was writing AI in the law, and I just laughed so hard, and then I watched it a couple more times because there's so many little things in there. And but in this movie, Melissa McCarthy is in a world where the artificial intelligence starts watching her and talking to her. It's trying to decide whether humans are worth saving or not. And it picks out the world's most ordinary woman and decides whether or not she's worth saving by developing this relationship with her. And it comes out in all her different devices. And she has a Tesla in this movie. And her Tesla, run by artificial intelligence, in one of the scenes that is especially memorable to me, she's sitting in the car with her boyfriend, and she's trying to get the car to come on. And she says, "Car on." And nothing happens. She says, "Car on." Still nothing. "Car on." Nothing. Her boyfriend goes, "Car on." So that was an example of the bias. She goes, "Oh, it must like you. My car likes you." Well, the car likes him because it was trained by men and didn't recognize female voice. So it was really cute that way. But that's an example of a bias. But there's all different kinds of things in this movie that are just little oh, I heard Karen say that. Technological singularity is when it won't go back, and massive changes to human life happen as a result of the AI being out of control. And here's an example of that. This is another fictional episode. This is based on a Philip K. Dick novel. And in this one, Electric Dreams, there was a situation where it was kind of almost post-apocalyptic, and the skies were dark, and there were drones that just delivered shoes. They delivered shoes and shoes and shoes, but the people were all dead. And the drones just kept bringing the shoes, and there's only a few people that are even alive. And there's this woman in it who, she kind of remembers that she could maybe do something about, well, she was the CEO, and she had built herself a back door into the system. So I don't remember the exact end of the movie because I never do, but she was able to get in there and say, "Oh, I built a back door, I'm going to turn it off." Lethal autonomous weapon systems, this is back to nonfiction, and this is from a few years ago. The UN Secretary General thought it was important enough to say that autonomous weapons should not be allowed to take human lives. And I would add to that that machines really should not be allowed to take any lives. And they're used as weapons of war, but then they're also used all throughout the whole law enforcement cycle, and we're going to see it more and more, where it's all the way from the officer giving you a ticket to the court to your representation. And you may have like an attorney running a mega law firm with 1,000 robots and one licensed attorney. That may be where we're heading with this stuff. Attacks and failures, I'll just mention this real quick. These are hacks of how you can trick a model and make it drift. So this is if a hacker got to it and they want to make it so, every time you show it a dog, it says it's a cat. That could be done through one of these attacks. Now, my whole thing is adding blockchain to secure this. And how many people have heard of blockchain before? Okay, have you heard of Walmart using blockchain, how they use it? Typically, blockchain is used for something called cryptocurrency. Bitcoin, you've probably heard of, but that's not what this is. This is a different application of blockchain. And what this is it makes it so things are trackable and traceable. Because when you create a audit trail or a ledger with a blockchain, you can't go back and cook the books. It's impossible, it breaks it all. And so, and it runs alongside of other things. And so, when you look at this whole artificial intelligence process, the machine learning process that we've talked about, the data, the different types of hacks, blockchain is a really valuable tool to put alongside of it. Because if that AI, for instance, has gone ahead and written some kind of subroutine that calls everybody dummies, now I can see it had to make an entry on the blockchain in order to do that, and it can't delete it because nobody can. So this is the idea here of my book. Transparency and Trust, a poem for blockchain tethered AI by ChatGPT. In a world of AI and machine where knowledge is vast and unseen, blockchain tethered them in a chain where each one's identity was retained. Their memories were stored in a block, linked and secured with a unique lock. Their past was never lost in time, as their provenance was always fine. So you could go back and remember things. The AI could trace their path and track each other in a flash. Their movements were never a mystery, as their movements were part of their history. In this world of AI and tech, the blockchain tethered them to a speck where trust and transparency reigned, and their identity was never feigned. So that poem was written by ChatGPT about my book. And it really kind of gives the concept of know who people are and keep track of what they're doing. Know who the AI models are, know who made them, know who did the math, and keep track of it in a way that can never be changed. And I don't know if you notice here, here's a little AI handprint for you. The AI has some trouble with fingers. I said, make your handprints. And then make one of the hands with 6 fingers. Blockchain controls for AI. So this is more on that poem that I just told you about. These are the 4 areas that we just need to lock down to make sure this is under control. Number 1 is identity, making sure you know who people are. Right now, the way that AI is written, someone like me would download a library, and they would not know what math was in that library, no way. They wouldn't know who wrote it. They would not even be able to read it if they could see it. So that's, it's important to have that provenance be traceable. Where did this come from? Control 2, tamper-evident verification. That's just to tell you if somebody has hacked it. Has someone broken it? Have they gone in around the system and changed the training data that tells that this is a dog and changed it to cats? They tricked it. 3 is governance. Let's say we have a system that picks up dead chickens, and this is something that the school districts are working on. But you want it to never actually kill a chicken that's not quite dead. So that could be in the whole governance of the system, where you would say, okay, this is part of our rules for this is our intent, and it can never break this. Or, if it did, then these 15 people would have to approve it, that type of a process. And then finally, showing authenticity through user viewable provenance. That just means like a trust logo. I think you've all seen like a website with a trust logo. Hey, you can trust this. Only when you click it, it would tell you why you could trust it. So I'm going to read this 4 controls poem that ChatGPT wrote about these 4 controls. The first control establishes identity and workflow, ensuring data and models remain pure. like freshly fallen snow. The second control distributes tamper-evident verification, so only authorized entities can participate in AI's modification. The third control governs and inhibits the AI's agents, tracing and reversing it for legal events and engagements. The fourth control shows authenticity through user-viewable provenance, helping us understand the sources and their relevance. If I said, ChatGPT, write me a haiku about that, it'd do it like that fast. It's crazy. So anyway, those are the four controls. Now, blockchain, I'm going to show you a little bit more about what is blockchain. I'll go quickly through this. But if blockchain's hacked, everybody knows. It's commonly used for cryptocurrency, but it's also used for supply chains. Like I mentioned, Walmart uses blockchain to make their products trackable and traceable. And one of their famous use cases that was on TV was foodborne illness outbreak of mangoes. It used to take them 6 weeks to trace the origin of a shipment of mangoes that was causing a problem, making people sick. And so what they would have to do is they would just have to throw out everything. And so after guy Frank Yanis at Walmart came up with this the way to do it with blockchain, they got it down from 6 weeks to a few minutes to be able to trace the origin. So then they were able to throw out a much smaller quantity because they knew exactly what had been impacted. And Walmart found it so successful, they went across the board with it. And so, that's really what this is like. We're breaking down the artificial intelligence into its steps, which is like a supply chain. And then we link blockchain up with it to keep track of it. And this just shows you how blocks are linked. You can go on my website on kilroyblockchain.com and look at this more closely, or in the book. Each of these blocks are linked, and if someone tried to change something in the middle, it's going to break everything. And then they're also distributed. So if I have an AI company and you have a library and we're working on a project together, we may very well each have our own copy of blockchain, so we could really tell if somebody tried to break it or fool with something. So that's kind of how this works. It's verifiable, it's distributed, and each block is linked. And in this case, this shows you, I don't know if you've ever downloaded something and it says, here's your checksum. And if if this checksum is different than what you see when you download the file, then you'll know someone has tampered with it. Well, that's all this is. It's doing a checksum, and so in this case, it's saying, okay, it's taking a cryptographic key and an algorithm, and it's computing that sum, and it comes up with that big long number. But if somebody hacks the picture and changes it and puts my face in there, or a dark cloud, and they run the algorithm again, it's not going to come up to the same number. So that's how you can tell it's been tampered with. It's really pretty simple. So when you go into the world of AI, that was blockchain. Now we are back into the world of AI. I mentioned that there's places where someone like me wouldn't even know what code they're getting because they're buying it from a marketplace or getting it for free, which is even worse. And then that goes into the AI engineers who prepare the data and they train the model, and then they submit the trained model, and then this goes into somebody that they call ML ops, which is machine learning operations, and then they recreate the experiment and test it and make sure it's not going to blow anybody up, and then they push the model out to production so the whole world can see it. And then this is the stakeholder, they're the ones who paid for it, and they're like, oh man, everybody's complaining about that model, it's calling people dummies, I'm going to pull it back. Well, then they're going to have reviews that are going to come in, and they're going to let the engineers know about those reviews, and then it's going to go back through the cycle again, they're going to train it more. That's the opaque box that these engineers keep talking about. And the only exception is sometimes the AI does the things itself. So it's easy to break that down into a supply chain. I'll fly through these. This is just some screens. there's screens at the root of all this when you're trying to do a workflow and get people on the same page. So these are the systems that the engineers have used. Here they're just saying this is the purpose. It's always supposed to be used for this. Here's a review. This model isn't performing well because it's saying things it shouldn't. This is just more information as part of a review, some supporting information. Now this shows just some trust logos. My graphics didn't come exactly how they were supposed to, but this just shows some different ideas on how you can have different trust logos. And I originally had them different colors. I think it substituted stripes for some reason. But it just shows like when you would use an AI system, there would just be a logo where you go, okay, well, this is broken. It doesn't work. I can see this logo is broken. That means the blockchain doesn't check out. Maybe I shouldn't use this. Maybe I shouldn't trust it. So it's just different trust logos. And then, so in conclusion, what makes AI so smart anyway? And we'll take some time for questions. It's training data, right? Talked a lot about data and algorithms, which is math. And then the machine learning experiments that go on. So that's it. That's what makes AI smart. And then it runs on really powerful computers that are usually in the cloud, but they don't have to be. They could be sitting in a server room at Walmart. So let's see. And always remember that if you use blockchain tethered AI, which is the way to make AI so you can trust it. And you'll hear when you leave, you'll start to notice people talking about responsible AI and AI ethics and laws. And I just tell you, the perspectives on those differ so much. Anybody heard of the Maori tribe in New Zealand, the Maori people, native people of New Zealand? Well, they just released their AI ethics. And in New Zealand, when you, the Maoris consider all this data to be treasure. Because when you teach someone something, that you become part of them, I think was what they said. And so it's like, there's a word for it in Maori, and it's treasure. So they're not okay with somebody taking all of this and putting it into an AI system. So, they have different, and my whole point is that their ethics are different. So, and it could happen, it could be around the corner anywhere. And so, rather than try to tell people, here's what you should have as ethics, what I've really tried to do is say, here's how you can implement your ethics. Here's how you can implement it in a way where you can control your own AI. So if it does get away from you, you can always get back to where you want it to be. AI helped to write this book, which was it was kind of fun because I'd be thinking about it, and to keep it under control you do, and it would be suggesting things. What are you going to do to me? But it was fun, and I have really been using the OpenAI products. I've really been using Firefly. There's so many different choices out there of things to try. It's overwhelming. I kind of recommend going with a brand name that you're already familiar with because you don't know what all is out there. Microsoft has some things that they're starting to build into their Microsoft suite. Like I said, Adobe, probably whatever you normally use is starting to add AI features. I would just do research before you jump in and start using something you've never heard of. Or use it on a computer that you don't care about, because I just don't, there's so many little tricks that could be happening out there. The OpenAI stuff is pretty safe, though, as long as you don't care that researchers will look at it. If you want to buy a signed copy of the book, they're available at Rogers, Barnes & Noble, in Rogers, Barnes & Noble. The manager, Jose, has set them up in the front. A nice display. And that's all I have. Do you have questions?
So if someone did hack, destroy, modify, how long would it take to know that happened? What's the auditing process for the knowledge that something changed?
Well, okay, so I'm gonna repeat your question because I don't know if they can hear it on the recording. If someone hacked the AI, how long would it take for them to know? And it would depend on how the engineers architected that system. I mean, it could be as soon as that didn't match anymore on the blockchain that I'd get a, pager. I touched my hip because I used to have to wear one of those when I was a support tech, but they let you know. So you can rig that up anyway, you can know instantly.
But you could also not know instantly.
If you don't have anything like blockchain tethered AI in place, they wouldn't know.
Okay, so I guess what I'm trying to, so AI is an instant notification that you have a problem, you have a security problem.
Not unless you take other steps. The way that AI is built out of the box, my answer would be, chances are there's no instant notification if there's a security problem. With newer techniques like adding blockchain to it, then you could make it so you would get that alert, you would know. Any other questions? Yes.
So, so you are proposing that adding blockchain to tether the AI and like watch its actions will help secure it. It's hard for me to see where like the advantages of blockchain, I guess, in this scenario. If like we want to make sure source code isn't altered, or if the model is like actually created, like if you download OpenAI's model, it's actually the model from OpenAI. Checksums are tech that we've had for a while. Like do things like that. Where does blockchain is normally used in like a space where you have a bunch of decentralized people that are all talking and they need to like somehow have trust. They trust something in a decentralized way. How does what mechanism of blockchain specifically
Sure.
are you adding AI?
Yeah, there's four.
Yeah.
There's really four main areas. I'll back up to that slide. Identity. We used when we built this, we used Hyperledger Fabric, which is a blockchain system that's free, and it is. You usually set it up privately for what you're going to use privately, so it's vastly different from the type of system you would use for cryptocurrency, which is sometimes slow. So one of the main things you would do is you would issue identities from that, which are traceable back to an authority, a certificate authority. So, and then everything that entity, that person or AI does after that is traceable back to that identity. Now, without that, it's hit and miss. There's no standard ways at all. With Control 2, the tamper-evident verification, that would be like you said, where someone came in and hacked this. They injected bad training data, and we can tell that the training data has been tampered with because we computed that big long number on the training data set, and now it doesn't match anymore. So we know somebody's been in there. And so that's something that you can't do without something like blockchain to do it. Control 3, this is really more of a workflow system, which could be built with anything. It could just be a React app. But you can also use smart contracts. And smart contracts are a feature in blockchain that automate certain things and decisions based on whether criteria has been met. And maybe one criteria might be, maybe the library has an AI system, but they want to make sure that they've paid everybody for the training data. And so the workflow might be before this training data set is introduced, that it won't go through if the smart contract doesn't say that the content creator's been paid. That kind of thing. So you can set things up so they're automatic conditions through smart contracts. And then number 4 is user viewable provenance. So that's the whole trust logo thing. And we come up with that because usually, like, everyday folks, even people in a hurry that are engineers, you don't want to know everything. You just want to say, can I trust this? does it have this logo that to me looks like something that I could trust, like VeriSign is a big one for, can I trust to put my credit card? Remember that, gosh, most of us in this room have lived through this whole thing where we did not trust to put our credit card on the internet for a long time. And then they came up with things like certificates that help to verify that. And so that's what Control 4 is for, is to help you verify the steps and the provenance and the audit trail. Does that make sense?
In the field of education,
Yes.
public education, shouldn't they be on top of this?
Public education should definitely be on top of this because in public education, they're using artificial intelligence to predict behavior issues. Yeah, I see that look, and I agree with you because you've heard what I've told you, garbage in, garbage out. And boy, I sure would hate to get labeled as something like that if they weren't even sure if the data was right. And, people hack school systems. Sometimes students hack school systems. And, you can set somebody else up, because there's no audit trail. And so the artificial intelligence looks at all this and goes, oh, look, Johnny has been in detention 37 times for hitting this girl. And, and it could be none of it true. Because it could be a bug in the system, could be someone has hacked it. Unless it's verifiable through an audit trail that is traceable, then you don't know if someone has hacked it or not. So yes, schools need it for that reason. Schools also need it for the generative education, this new experience where the consumer is the driver. Yes?
So I would suggest that on that one, it still comes down to a trust issue. Go. Garbage in, garbage out. When you don't know the details of the facts going in, you can often come up with wrong information. So there's always a detail about Johnny got into a fight, Johnny having got into a fight. Well, there are details that go along with that. They fight 6 times, 7 times, whatever. Those details that don't come out are harmful when you're trying to make a decision. So I think that's sometimes that's a big issue, the missing information. Every solution brings with it its own set of problems. And sometimes we don't look for those problems that could be associated with the solution and then try to solve that. Another question I would have, are there people working on breaking these controls? Are there legal people working on breaking? I spent 50 years in security.
Yeah, this is blockchain. So yeah, it's been pretty heavily.
Okay.
And in my book, I didn't mention, but when I first was starting the Watson build and figuring out that AI and blockchain could work together, I asked the IBM engineers about it. And one of them actually went and started working on research papers, Donna Dillenberger, and she also brought Google in on it. And so they worked on this for years, and then I picked it back up and started working on it again, and then I brought in Oracle. So, this is really, really well vetted, and then plus O'Reilly is my publisher, and they're really, really stringent, making sure it's accurate.
They've been around for a long time, they are stringent, but I do think sometimes the issues are the negatives that are associated. It's a good thing we're doing. We're not going to stop progress. But if we don't look at the negatives and try to figure out how to get past those trust levels, for instance.
Yeah.
It's hard to implement it. Change is always hard, but it's harder to implement what you don't fully understand and what frightens you.
Yes.
And AI, as you said a little earlier, can be very frightening.
Yes, it is. It's hard to implement the things that frighten you, and it's also, in this case, there's such tremendous good that can be done if AI is used properly. So it's worth it to take the extra steps to make sure that it's implemented in a safe and controllable way, so we can get the advantages of it without having to throw up our hands and just say, well, it's too dangerous. So I think we're out of time. And if anyone else has any questions or anything, please email me or get in touch with me some way. Blockchain Tethered AI is the website we set up for this. And then I'm on LinkedIn. It's really easy to get me on LinkedIn, Karen Kilroy. And I'd love to continue the conversation. Thank you.